Hi friends, today we see about very important topic in circuits theory, that is Kirchhoffs laws. Okay, so in Kirchhoffs laws there is two laws, current law and voltage law. First we see Kirchhoffs current law. The definition of Kirchhoff current law: the sum of currents entering a junction is equal to the sum of the current leaving from a junction, or the algebraic sum of all the current meeting at a junction is 0. Now we see the example. In this circuit, I1, I2, I3, I4 and I5 are different current entering to the node, or this is the junction. Now in this circuit, I1 and I3 currents are entering to the node and I2, I4, I5 currents are leaving from the node. Okay, by the definition, what is the Kirchhoff current law states that sum of the current entering to the node is equal to sum of the current leaving from the node. So by applying this current law, I1 plus I3 is equal to I2 plus I4 plus I5, because I1, I3 currents are entering to the node, then I2, I4 and I5 currents are leaving from the node. Therefore I1 plus I3 equal to I2 plus I4 plus I5. Okay, so or it may be written as I1 plus I3 minus I2 minus I4 minus I5 equal to 0, because the algebraic sum of all the currents meeting at a junction is 0. By this definition we may written as I1 plus I3 minus I2 minus I4 minus I5 is equal to 0. Okay, next we saw Kirchhoff's voltage law. Second law: in the closed circuit, the sum of potential rise equal to sum of potential drop. Okay, the other definition: the algebraic sum of the potential difference around a closed circuit is 0. Okay, the Kirchhoff voltage law only applied in the closed circuit or loop. For example, see the circuit, simple circuit. R1, R2 are connected in series. The voltage is applied to this circuit. So the potential rise or potential difference between the resistor R1 is V1 and potential difference between the resistance R2 is V2. Okay, now applying Kirchhoff's voltage law, sum of potential rise is equal to sum of potential drop. Okay, so V is the potential rise, that means that is the source, and V1 and V2 are the two potential differences that drop the voltage from the given source voltage. So V1 and V2 are the two potential drops. Therefore V is equal to V1 plus V2, or it may be written as V minus V1 minus V2 equal to 0, because all the sum of all the potential differences around a closed loop is 0. Okay, so we may written as V minus V1 minus V2 equal to 0. Next see other important law, that is Ohm's law. So Ohm's law defined as at a constant temperature the potential difference is directly proportional to the current. Okay, the potential difference V is directly proportional to current I. Okay, by changing the proportionality we include the proportional constant, that is R, that is the resistance. Okay, so V is equal to IR, that is the main result of the Ohm's law. Okay, so where R is the proportional constant. So when will be the Ohm's law is applied? It is only at a constant temperature. Okay, so this is very important. If the temperature is changing, the Ohm's law does not follow in that situation. Okay, only it allows at a constant temperature the potential difference is directly proportional to current. Okay, next we will see about series and parallel circuits. So R1, R2, R3 are the series resistance connected in this circuit. The voltage V is given to the circuit, then the current I flows through the resistor R1 and R2 and R3. Okay, in series circuits or series connected devices, the current I is same in R1 and R2 and R3, but the voltage is differs. Voltage across the resistor R1 is V1 across R2 is V2 and across R3 is V3. Okay. By applying the Kirchhoffs voltage law, potential rise, that is V, is equal to potential sum of potential drop, that is V1, V2, V3, V1 plus V2 plus V3. Okay. Now we apply the Ohm's law. V is equal to I into R. I into R equivalent, that is equal to V1 is equal to IR1 plus V2 equal to IR2 plus V3 is equal to IR3. Okay. Now take I as common, take it out, then I into R1 plus R2 plus R3. Cancel it, I into I. Okay. Then remaining R equivalent is equal to, that means equivalence resistance for this circuit is R equivalent equal to R1 plus R2 plus R3. Okay. For any series circuits, the R equivalent is R1 plus R2 plus R3 if the resistors are connected in series. Okay. Next we will see about what is the equivalent resistance if the resistors are connected in parallel. Consider this circuit. R1 and R2 resistors are connected in parallel. The given voltage V and the current to the circuit is I. In this node, the current is splitted. Okay, then I1 and I2 currents are flow through the R1 and R2 resistors respectively. Okay, by using Kirchhoff's current law, the given current, that means the entering current in a node is equal to sum of the current leaving from the node. Here, this is the node. Okay, the I current is entering to the node and I1, I2 currents are leaving from the node. By using this law, we may written as I is equal to I1 plus I2. Okay, by Ohm's law, I is equal to V by R equivalent, that is equal to I1 equal to V by R1 plus I2 is equal to V by R2. In parallel circuits, the current is differs, but the voltage across the resistor R1 and resistor R2 is same. Okay, then V by R equivalent is equal to, V is common in both the terms, so take it out, then remaining 1 divided by R1 plus 1 divided by R2. Now you cancel this V and this V. Therefore 1 divided by R equivalent is equal to 1 by R1 plus 1 by R2. Now you take the LCM, the final solution, that means 1 divided by R1 plus 1 by R2 is equal to R1 plus R2 by R1 into R2. Okay. Now what is the resistance equivalence? Now you take the reciprocal. Once you take the reciprocal means you will get the equivalent resistance. Therefore R equivalent equal to R1 R2 by R1 plus R2. So this is the basics in the circuit law. Okay, thank you very much.